In this video, we're going to be taking a look at the second derivative test for relative extrema. So in a previous video, we learned that if we take the first derivative of a function, set it equal to 0, we find what are called critical values. And those critical values are where our relative extrema are. That is where our relative minimums or relative maximums are. And the relative minimum would be like the low point, and the relative maximum would be the high point. What we don't know is which one it is. When we find the critical values, all we know is we have a relative min or relative max. The second derivative test for relative extrema will tell us which one of these it is by using the second derivative. If the second derivative at this point is positive, then we have a relative minimum. If the second derivative is greater than 0. And we learned that in a previous video, that this is concave up, and the second derivative is always positive where the graph is concave up. So where the second derivative is positive, we are going to have a minimum. Likewise, we learned that where the second derivative is less than 0, we're going to have a graph that is concave down. Well, what that means now is the second derivative is less than 0, we have a relative maximum. And so that makes sense that this point is going to be a maximum value, a relative maximum. So what we need to do is we use the first derivative, set it equal to 0 to find our critical values. Then we have to take the second derivative and evaluate those critical values at that point. So let's do an example. Given this function, determine the critical points or critical values, and then use the second derivative test to determine if they're relative max or mins. So let's find the critical values. F prime of x is going to be equal to 3x squared minus 12x. Set that equal to 0. Factor out the 3x, and we'll be left with x minus 4 equals 0. Set both of these factors equal to 0 using the old zero product property, and we get x equals 0 and x equals 4. These are our critical values. These are critical values. We either have concave up or concave down, a relative max or relative min. But which one is it? We don't know. Now, to determine that, we can go to the second derivative test. So let's find the second derivative of this function. Second derivative of this would be 6x minus 12. And now let's evaluate both of these points in the second derivative. So let's find f double prime of 0. That's 6 times 0 minus 12 is negative 12. So what we're really concerned with here is the negative part. Because the second derivative is negative at 0, we know that it is concave down, and therefore we have a max, a relative max. That's the second derivative test. Now, to find the second derivative at 4, we have f double prime of 4. So that's going to be 6 times 4 minus 12, which is 4 times 6, 24 minus 12 is positive 12. What we're really concerned with is that the second derivative at 4 is positive. That means we have a graph that is concave up at that point. And if it's concave up, then we have a relative minimum. So we have a minimum at 4 and a maximum at 0. Let's do another example. So we have the function x cubed minus 12x. So let's start by finding the critical values. So that will be 3x squared minus 12. Set it equal to 0. Then we have 3x squared equals 12. X squared equals 4. Or x equals plus or minus 2. These are our critical values. Okay? Critical values, where the first derivative is equal to 0. Now, to determine if they are maximums or minimums, we evaluate them in the second derivative. So the second derivative of this will be 6x, just 6x. And so the second derivative evaluated at positive 2 is 6 times 2 is positive 12, which means we're concave up, which means we have a relative minimum. The second derivative evaluated at negative 2 is 6 times negative 2, which is negative 12, which is concave down, which means we have a relative maximum at negative 2. So we have a relative min at x equals 2, and we have a relative max at x equals negative 2. Let's do one more problem. So in this one, we will find the first derivative, set it equal to 0, and we get 2x minus 4. Set that equal to 0. 2x equals 4. X equals 2. So now we just have one critical value. One critical value. But is it a max or is it a min? So once again, let's go to the second derivative test. The second derivative of 2x minus 4 is simply 2. So there is no point of inflection. And in a previous video, I explained that if the second derivative is a constant, and this constant is positive, that means it's always concave up. And if it's always concave up, that means that this point must be a minimum. Well, let's just suppose, so we have a relative minimum at x equals 2. Let's just suppose we had a second derivative that was negative 8, a constant that was negative. Well, that means that it's always going to be concave down, always, which means that our critical value would have to be a relative maximum. So sometimes people get a little bit confused when you don't have a variable in your second derivative, but it's a constant. What you're concerned with is the constant positive. If so, then we have a relative minimum. Is the constant negative? If so, we have a relative maximum. So that is the relationship between concavity and the second derivative and second derivative test.